Okay, so good morning and welcome to everybody who's joined us here for the International Wilderness Week event organized by the European Wilderness Society. So I'm Sangeeth Sailas and I'm a master's student at the Salim Ali Centre for Ornithology and Natural History in India. And today I'll be talking about my master's project that I was involved in the earlier half of this year, which is on the factors influencing the habitat use of owls in a mosaic landscape in Garo Hills, Meghalaya. Now, before I get into the actual research, I'd like to give you just a brief introduction about why I chose this particular topic for my master's project. So I've actually been, fascinated by these generally nocturnal predatory birds for quite some time now. Ever since I was involved as an intern for a project in central India where I was doing surveys for the endangered forest owlet. So when I joined the master's program at SACON, I was quite keen to work on owls for my dissertation. And another reason is that owls are unfortunately understudied in India, even though we have more than 30 species. There haven't been much studies done on them, with the exception of the endangered forest owlet, which has received quite a bit of attention. And the second part of the question is, why did I do the study in northeastern India? So northeastern India is actually a biodiversity hotspot and part of the Indo-Burma region, where historically there have been records of 20 species of owls. But again, unfortunately, not much studies have been done on them, and particularly on habitat use of owls. There haven't been any studies done in this region at all. And also, the northeast of India is also facing a lot of biodiversity conservation issues, like the loss of natural habitats due to the reduction in the fallow periods of shifting cultivation, or Joom as it is called over there, which doesn't leave enough time for the forests to regenerate, and other issues like encroachment into protected areas and grazing. So, keeping all of this in mind, I decided to do a study uh, in Garo Hills of Meghalaya, which is a part of northeastern India. And this landscape is actually a mosaic made up of forests, agriculture fields, plantations, and settlements, along with these particular type of community conserved area called community reserves, which are scattered across the landscape. So community reserves are actually protected areas where the ownership of the land is with the local indigenous tribes, and they manage it in consultation with the forest department. So we expected that these community reserves would actually act as a kind of refuge here for several species, um, because they make up, the majority of the protected area network in this part of in this region. And since the surrounding landscape is undergoing drastic habitat degradation and alteration. So to understand habitat use of owls in particular, I came up with two objectives for my study. And the first one was to assess the influence of ecological correlates of habitat on the occupancy and abundance of owls in the study area. And two was to compare habitat use of owls inside and outside community reserves. So as I mentioned before, I selected the Garo Hills of Meghalaya as my study site. But to be more specific, I surveyed in and around community reserves in East and West Garo Hills districts. So initially, I had planned to survey in 10 such locations, but because of the ongoing COVID pandemic, I had cut it short and I was only able to survey in four such locations. Now, this region experiences a humid subtropical climate, and the elevation ranges between 800 to 1300 meter. And this landscape is also like the larger Garo Hills landscape, a mosaic made up of agriculture fields, orange plantations, plantations for other crops, other cash crops, degraded and undisturbed forests, and settlements, and of course the community reserves. So for my sampling design, I overlaid 4 square kilometer plots around each of the community reserves. So this is an example of one such community reserves. And then I divided these 4 square kilometer plots into 16 500 into 500 meter grids. And then I use alternate grid sampling to select my survey stations in each grid. And this size of 500 into 500 meter was chosen since it's known that the territory size of many small and medium sized owls is comparable or lesser than this size. Now, for my owl surveys, I had three survey protocols. And the first one was listening to spontaneous calls, where I would wait and listen for any spontaneously calling owl um, after sunset for 5 minutes. Now, this would be followed by the call playback method, where I would play back the calls of the owls that I was surveying for, which totally numbered 13. And I would play the call of each species for half a minute, followed by a response period of 1 minute. And both these protocols, I would note down the number of individuals, number of species, and approximate distance at which they were calling from. Now, this would be followed by the third survey protocol, which is spotlight searches, where I would use flashlights to search in the vicinity of the survey station for any non-responsive owls for 2 minutes. Now, since I was planning to take into account detection probability, I also considered several sampling covariates such as moon phase, temperature, relative humidity, wind speed, and survey start time. And for the factors that I expected to influence occupancy and abundance, I considered several site covariates. And these included vegetation parameters such as tree GBH and height, canopy cover and height, understory height and cover, number of logs, and number of dead trees. I also created a disturbance index by summing scores that I gave for felling, logging, grazing, and evidence of recent fire. I also considered several spatial parameters such as slope, terrain ruggedness index, distance to water body, settlement, community reserve, and primary forest. Now, for my data analysis, I initially conducted a variable screening where I removed highly correlated variables, and these were the ones that had Pearson's correlation coefficient greater than 0.6. And for the factors that would influence occupancy of owls, I used single season, single species, single season occupancy models. And for the factors that would influence abundance, I used the Poisson variant of N mixture models. And both of these were done using the package unmarked in the R software. Then, to compare habitat use of owls inside and outside community reserve, I tested whether there was a significant difference between number of detections of owls inside and outside community reserves using the Madden-Whitney test. So in the end, I found that I had detected 5 species of owls, with the brown wood owl, mountain scops owl, and the collared owlet having the most detections. And so the analysis was done for these 3 species. Now you might be wondering, why I only was able to detect 5 species of owls in total when I had initially surveyed for 13 species. So I have several possible reasons for that. So one could be the reduced survey effort because of the ongoing pandemic. So initially I had planned to survey a much larger area, and that was not that didn't end up being possible. So I could have missed out several species because of that. Another reason could be seasonal variations in vocal activity that I could not have accounted for, since we don't know much about many of these species. And there could also be seasonal movements of owls, and I only surveyed in the in the upper elevation. So again, I could have missed out some of the species. Uh, so coming to the results for the brownwood owl, I found that wind speed had the greatest effect on both detection probability of occupancy and abundance, and this was a negative relationship. So one reason for this could be thermoregulation, since higher wind speeds can negatively influence heat retention. Another explanation for this could be just that the observer is not as efficient at detecting owls at higher wind speeds. In the case of occupancy and abundance of the brownwood owl, I found it to be most influenced by slope and distance to stream, with both of these being negative relationships, meaning that this species was more likely to occur and was more abundant in areas that had gentle slopes and were closer to streams. Now, in the case of the barred owl, which is a congeneric of the brownwood owl, It is also known to prefer to use areas that have gentle slopes, and this is attributed to its prey distribution. Another congeneric of the brown-wood owl, the spotted owl, is known to uh, be associated with streams because its prey species, which are flying squirrels and wood rats, they are also known to be associated with streams. So again, it could be something very similar in the case of the brown wood owl that is driving its relationship with slope and distance of stream. Another possible explanation for the negative relationship with distance to stream could be thermoregulation, since temperatures are known to be lower closer to streams. In the case of abundance of the brown wood owl, we found it to be also influenced by GBH and heterogeneity of tree height, with both of these relationships being positive. Now the positive relationship with GBH is something that uh, we expected because the brownwood owl is described to be a deep forest species by Ali and Ripley and an old growth forest specialist by Marquardt. And such areas would obviously be where such large growth trees are found, which would definitely be important for this large bodied cavity nesting species. The positive um, relationship with heterogeneity of tree height um, in the case of the brownwood owl can also be attributed to thermoregulation, as it is in the case of the congeneric spotted owl. The spotted owl is a species that is known to roost in areas where there are both large and small trees in the surroundings, and it is known to roost in the smaller trees, smaller and shorter trees when the weather is warmer, and in the larger trees with denser canopy in when the weather is colder. So again, it will be something very similar that is driving the relationship of the brownwood owl's occupancy and abundance with heterogeneity of tree height. Now, in the case of the mountain scarps owl, um, we found that temperature had a positive relationship on its detection probability, and detection probability of abundance was also found to be influenced by humidity, with this being a positive relationship again. Now, one explanation for the positive relationship with both temperature and humidity could be the effect of temperature and humidity on the speed of sound. So, at higher temperature and humidity, the speed of sound actually increases, which means that it attenuates less, meaning that it will also travel further. So, perhaps the mountain scarp sound is making use of this environmental phenomenon and being more vocally active when it's called to travel further. Another explanation for the positive relationship with temperature could be thermoregulation, since lower temperatures can negatively influence heat retention. In the case of occupancy and abundance of the mountain scarps, we found it to be most influenced by distance to stream and disturbance, with both of these being positive relationships, meaning that this species was more likely to occur, was more abundant in areas that were away from streams and were relatively more disturbed. Now, the flammulated owl is also a species that is known to prefer to use relatively more disturbed areas where there are a higher diversity of rodents and insects. Um, because of the because of more gaps in the canopy, which would facilitate a denser understory. The flammulated owl is also known to avoid large bodies of water, um, which is attributed to its intolerance to humidity. So again, it could be something very similar in the case of the mountain scarp owl as well, that is driving its positive relationships with distance to stream and disturbance as well. Now, in the case of the collared owlet, we found the temperature had a strong positive effect on its detection probability, with detection probability of abundance being also influenced by survey start time, with this being a negative relationship. Now, the effect of temperature on detection probability can be attributed to the effect of temperature on speed of sound and thermoregulation, as it was in the case of the mountain scarp owl. And in the case of the negative relationship with survey start time, this is something that is again expected because the collared owlet is a member of the genus Glaucidium, and Glaucidium owlets are known to be more diurnal or crepuscular than other owls. In the case of occupancy and abundance of the collared owlet, we found it to be most influenced by slope, with this being a positive relationship, meaning that this species was more likely to occur and was more abundant in areas that had steep slopes. The spotted owl is also known to prefer to use steep slopes, which is attributed to its prey distribution. So again, it could be something very similar that is driving the relationship of the collared owlet's occupancy and abundance with slope as well. But the weak relationship with the other habitat covariates probably suggests that this is a generalist in nature. And the Mann-Whitney U tests that we did revealed that there were indeed statistically significant differences between the number of detections inside and outside community reserves in the case of the mountain scops owl and the brownwood owl. Now, in the case of the mountain scops owl, we found it to be more detected more outside the community reserves. Now, this is something that is also supported by the results from the occupancy and abundance modeling, which showed that this species preferred to use more disturbed areas, which would naturally be outside the community reserves. Now, in the case of the brownwood owl, was detected much higher inside the community reserves. Now, this is also something that is understandable since, as we found out, the community reserves were actually the least disturbed areas in the landscape outside the Nokrek National Park, and also were the only areas that still had old growth forests outside the Nokrek National Park. So such areas would definitely be again important for this old growth forest specialist. So I think the study points out the importance of accounting for detection probability in owl surveys because we found a strong effect of sampling covariates in the case of all three species. And the finding that distance to stream and GBH were important site covariates indicate the necessity for conserving streams and old growth forests in this landscape. And finally, the higher detections inside the community reserves of brownwood owls, which are an old growth forest specialist and a species that is currently considered to be in decline by Marcode, indicates the need to maintain community reserves in the Garo Hills landscape. Now, before I conclude, I would just like to thank the Ministry of Environment, Forests and Climate Change of India for funding the master's program at SACON. I would also like to thank Raptor Research and Conservation Foundation for their generous scholarship that enabled me to participate in this study as well as the master's course at SACON. And uh, and also I would like to thank Mr. Kiran Srivastava of RRCF for his support and the Meghalaya State Forest Department for their necessary permissions. I would also like to thank Dr. Shankar and the course director of SACON, Dr. Jayapal. Dr. Shankar is the director of the institute, for both of them for their support. And also, I would like to thank my supervisors, Dr. Pramod and Dr. Babu, for all their guidance. And I also want to thank Dr. Karunagaran for who's the PI of the Meghalaya Community Resource Project, for letting me be a part of the Community Resource Project of SACON in Meghalaya. So thank you. And if there are any questions, I would like to hear them.
Thank you very much, Sangeeth, for your wonderful insight into owls in the northeast region of India. So yes, does anyone have any questions for Sangeeth at all on this presentation? Don't forget, you can also raise your hand to ask him directly, or also write in the Q&A or in the chat. So we'll leave a few seconds for that and see if anyone comes up with anything. Okay, just to give the attendees a few more minutes to think about the questions I have for myself, for you, okay. Sangeeth. Generally speaking, do you think that wilderness, so old growth forest areas and other untouched pieces of land, do they generally improve the habitat quality for owls, or is it really dependent on the species themselves?
Yeah, I think it's would be dependent on the species, because some species might prefer to have at least maybe a moderate amount of disturbance, like like in the case of the flammulated owl from literature, and in the case of the mountain scarps owl, as from the study. But yeah, it would be keeping such old growth forests intact would uh, definitely be important for at least for the old, because there would be several old growth forest specialists as well. So for those species, definitely would be important. Yeah.
So if the old growth forest specialists, for example, the brownwood owl,
Yeah.
if the old growth forests were to disappear from the region, would the brownwood owl also disappear with it?
Probably, yeah, I think so, because uh, the way it's described in literature is that it's only there in the old growth forest, and also maybe in the edges. So if there are no old growth forests, then also again, there wouldn't be any large trees with large cavities for it to nest in. So uh, yeah, if if they disappear, then it's very likely that the brownwood owl would also disappear, or at least suffer a like very high reduction in the population.
Okay, okay. So we have a question from Ingrid from the Rewild Institute. What do you think? Which meaning does wilderness have on certain owl species and other wildlife in India? So what is the meaning of wilderness to certain owl species and other wildlife in India, in your opinion?
uh, so uh, so wilderness, what I understand is that wilderness is are areas where they're not affected by destruction and degradation. So um, and if you're talking about each for certain owl species, okay, yeah, for the brownwood owl, I guess the meaning for wilderness would be old growth, tracts of large tracts of old growth forests where that hasn't been affected by habitat degradation or destruction. But for maybe for the something like like the a brown fish owl, it might be riparian forests along streams and rivers, which are again not um, mm, affected by habitat degradation. For something else like the forest owl, it might be um, teak forest. So yeah, for to each species its own, I guess. Yeah, I don't know if you can uh, you can have one definition for wilderness for a group of species. um, yeah, thank you for the question.
Anyone else have any further questions that they'd like to ask Sangeeth? In that case, I've also got another question for you. So,
Okay.
So, in terms of the ecosystem role that the brownwood owl plays in the old growth forests, what importance does the brownwood owl have in the ecosystem? What is its roles, and how does it support other species in the ecosystem?
Well, the brownwood owl would be feeding on rodents and also uh, other small mammals, and uh, possibly also on some species of birds. We don't. There hasn't been any studies done on the diet of the brownwood owl, as far as I know. But from literature, this is what we know. So it would be keeping populations of rodents in check in these old growth forests, definitely. And especially like rodents that are active in nocturnal rodents. And in the regions where I surveyed, I couldn't find um, many larger owls, much like the spot-bellied eagle owl and the dusky eagle owl. I could not detect them. So possibly their populations are much less. So in that case, the smaller owls like the collared owlet, Asian barred owlet, and the mountain scops owl, they wouldn't be able to fill the role of the brownwood owl in case it disappeared, because the brownwood owl would would be eating much larger rodents and smaller mammals compared to the smaller owl species. So yeah, that.
Brilliant. Thank you very much for answering all those questions. Also, thank you very much for sharing your research on the owl population in Northeast India with us.
Thank you for the opportunity.
Yeah, thanks for participating in the International Wilderness Week.